nucleare pentru conservarea obiectelor de patrimoniu din lemn în perioada 2016-2020. În cadrul acestor proiecte s-a realizat un transfer de cunoaștere de la ARC-Nucléart la IFIN privind aplicarea tehnicilor nucleare pentru dezinfecția obiectelor de patrimoniu și consolidarea obiectelor din lemn foarte degradate prin impregnarea cu rășini și reticulare în câmp de radiații. Din 2015, Institutul de Fizică Atomică și Comisariatul pentru Energie Atomică, cu sprijinul Institut Francez de Bucarest, derulează un concurs pentru restaurarea obiectelor de patrimoniu din lemn, organizat de IFIN-HH și ARC-Nucléart împreună Salvăm Patrimoniul Românesc. Despre toate acestea veți afla informații în conferința susținută de dr. Laurent Cortella, de la Comisariatul pentru Energie Atomică și Energii Alternative de la Grenoble. Dr. Cortella este șeful instalației de iradiere gamma din cadrul Laboratorului de Cercetare și Conservare a Patrimoniului ARC-Nucléart. Doresc succes, mulțumesc pentru atenție. Bogdan?
Thank you, Ioana. So now I will pass the word to Laurent. Welcome to our school, Laurent, and you have the floor.
Okay, thank you very much. Thank you, Ioana. Thank you to the organization, dear whole. First, okay, that's right. This is the summary of the presentation. I will begin with this presentation with a short introduction about ARC-Nucléart on some very few fundamentals, but radiation for those that are not so familiar with such topics. And I will then develop the two main original applications we use in our workshop, namely gamma biocidal treatments and consolidation with radio-Curable resin. And in both parts, I will try to focus on some particular activity and on restoration of sculpture on one hand, and conservation of archaeological wood on the other hand. And finally, instead of a real conclusion, I will try to highlight our collaboration with Romania. So let's start with the short introduction. The structure in which I am working is called ARC-Nucléart. ARC being for atelier, workshop, for research and conservation. On nuclear, wanted to express the idea of a link between nuclear and art. It is born in the early 70s, 50 years ago, from the idea of using nuclear techniques for heritage conservation. It is located in Grenoble. Grenoble is the biggest city of French Alps, and our building are just on the middle of a big research center of the French Commission for Atomic Energy, the CIA. Today, ARC-Nucléart have special status. It's kind of consortium of public organisms. CIA is the first partner. Other members of the consortium are Ministry of Culture and the city town of Grenoble, and also a small association that support us. ARC-Nucléart is thus acting like a small company offering its service for conservation of cultural heritage. Our customers are museums, local communities, other conservators or restoration workshops, and even some private individuals. The staff is 19 people. They are conservators, curators, biologists, physicians, chemists, technicians, also mechanic, one photographer, and of course some administrative. We use 3,000 square meters of facilities. With our main tool is an irradiator, but we have also two large-scale two large-scale freeze dryer. We have impregnation tanks, big one also, restoration workshops, storage rooms, chemical and biological analysis laboratories. And our current activity today is going far beyond the activity directly associated with irradiation, but all this activity can use as a tool, among other techniques, the irradiation, the gamma irradiation. With the biocidal treatment of the collection, which is the main activity with gamma irradiation, we have two other main specialties in the grouping that are the conservation of waterlogged archaeological woods and the restoration and conservation of wooden sculpture and historical polychrome woods. Other mission concern research and development, trying to improve our techniques and valuation also of our resources and competencies for other programs, like qualification for nuclear industry or for special industry, something like this, using gamma irradiation. For instance, we also carry out some treatments of piece of wood used to make knife handles that resist to the repeat passage to the dishwasher. It's just some few activity like this. And finally, we have a public mission of dissemination and training about all these activities. And this is what I have the pleasure to do today, dissemination. So you can see we are kind of both laboratory and workshop. So now I would like to give some very few fundamental about gamma rays, which is our main tool. What is gamma ray? Gamma ray is light, but it's not the common light. It's not the visible light. It's a kind of particular light like UV or X-ray or infrared, but on the more energetic side of the spectra. On that side of the spectra, we see the light as a flux of particles. These particles are named photon. Indeed, we say gamma rays when photons are emitted from radioactive nucleus of atoms. That's why we say it's a nuclear radiation coming from the nucleus. It has a low probability of interaction, but when it finally interacts with an atom, it will be with the electronic pulsation of the atom, making ionization and excitation of this electron. What is very important to understand is that that kind of radiation is completely unable to interact with the nucleus. Thus, it cannot generate any radioactivity at all. One important feature of this radiation is that because of the low probability of interaction, it is very penetrative. It can pass through large thickness of material before it interacts. It means that with such radiation, we are able to reach the inner of artifacts, for instance. Another feature that interests us is that it produces biological effects that, according to those, can cause the death of organisms. This is our facility. It's a pool irrigator using cobalt-60 radioactive industrial sources, very powerful ones. An artifact can be irradiated in the irradiation chamber, which is a kind of bunker with wall of 1.5 meter of concrete and with very high intensity of radiation. So now let's explain the first application of this gamma rays for conservation, just the use of biocidal power, excuse me, of this kind of radiation. The idea is that with this radiation we can fight against biodeterioration. Biodeterioration is just the natural way to eliminate waste from organic materials. So it's completely natural, but it also leads to serious and irreversible damage in cultural heritage collections. Made of wood, made of paper, made of leather, any kind of organic materials. Main pests are insects and fungi, rot, mold. The idea is that we can stop such damage by simple exposure to gamma ray, that's just a matter of dosage. The unit of dose is the gray. For insects, we know that we will reach the deterministic death. It means whatever the life stage, whatever the species of insect, after 500 gray. Over this dose, the more it is irrigated, the more the insect will die quickly. Talking about microorganisms and fungi, it's not exactly the same. The death will come in probabilistic manners. For more species, doses between 500 gray and 1 kilo gray will kill 90% of population. It is said the D10 lethal dose. This is the dose that lets 10% of survivors. If you irradiate again with the same dose, you will kill again 90% of those survivors. So you will get only 1% of survival. So the dose to apply against fungi will theoretically depend on the initial bioburden on the different species, on the level of cleanliness you want to reach. But by default, we use doses between 5 and 10 kilograms. Just to have an idea of what those mean, these doses, classical doses we can meet in human activity, for instance, radiography, are about milligram, while few gray will kill human in deterministic way with on the other side of the scale, the standardized minimum dose for medical sterilization is 25 kilograms, able to kill any form of pathogen, reducing the population to a non-dangerous level. So when you apply that kind of treatment to cultural heritage, one thing very important is the harmlessness. Behavior of material under irradiation have been largely studied for nuclear application, for space, for medical, for pharmaceutical and cosmetic sterilization, for food sanitization, and also for cultural heritage. we know that once again it's a matter of dosage. The first effect that can give us some problem with cultural heritage is the activation of color center in transparent material. It can occur even before 1 kilogram at a slightly level, but it can happen. So we must avoid transparent material. We know that. Then, depending on the type of material, at about tens of kilograms, you can have what we call cross-linking, new bonds between molecules that can be understood as a kind of stabilization of the material, but it is also a modification of the original material. And then at higher dose, we will have transition and radio-oxidation, which are obviously kind of deterioration. So this happened, let's say, after tens of kilograms. So we see that we can use safely 10 kilograms for most of the material. Here is, for instance, some result about pigment and painting, because color change in transparent material have been the first concern. We verified that European traditional pigment and binder were very resistant to irradiation, at least until 100 kilograms, which is much more than what can be used for those treatments. So how do we proceed? I will give this example of the irradiation for insect eradication we done recently on Japanese palanquin with lacquered wood. Firstly, we have to set up the artifact in a place in the bunker, in the irradiation chamber, where we know the intensity or dose rate of radiation. Then we evacuate the chamber, close the door, and pull up the source into the irradiation chamber to initiate the irradiation. This is what we can see in the chamber. You can see the source rack just in front of the palanquin, and the kind of tube of pencil you can see. These are the sources. We have to turn the object at mid-irradiation in order to have a good homogeneity of doses. And then we start again the second part of the irradiation. So we said that the efficiency of the treatment is directly linked to the dose, but the reliability of the treatment is given by the mastering and the control of this dose. Are we able to control that every part of the object have seen these doses that ensure us that we have a good treatment? For instance, always with this Japanese palanquin, we can model the palanquin by an homogeneous parallelepiped to set the condition of irradiation. So we can calculate the dose rate and then integrate the dose rate and the exposure time, taking into account a reversal at half irradiation. And not surprisingly, we have the maximum dose in both front side and back side that are symmetric because of the reversal, on minimum dose on the middle, left on the right side on the top, because in this case the artifact is higher than the source rack. And we can control the calculation result using just routing dosimeter, and the result is usually in very good accordance, usually better than 50%, and whatever better than 30%, which is enough for this application. We just have to know that we have overpassed the 500 grades that are the threshold for the insect eradication. So you can see that it is very good reliability because of this. It's quite very different from other techniques that use diffusion of liquid or gas to kill the insect, and this is very difficult to control. So from 50 years, we have started this activity. We have treated tens of thousands cubic meters of cultural heritage, artifacts, furniture, for instance, wooden sculpture, a lot, ethnological objects, musical instruments, natural history specimen, and also modern art. Something quite new for us in France is the archive decontamination, paper decontamination. Some years ago, we have done the decontamination against fungi of molds, and it was 11 linear kilometers of archive of our national archive that after a large-scale disaster in one building of national archive. But it is widely used, I think, around the world by many others, also in Romania. And of course, we have some very exotic customers like this frozen baby mammoth that we treated in 2010 for sanitary reasons, in order to kill potential dangerous bacteria like anthrax bacillus, but which in turn help to its conservation, killing also all the microorganisms that can deteriorate this specimen. And also some mummies, the most famous one being, of course, Ramses II, that was treated by our workshop in 1977 for fungi concerns. I would like now to do a focus on polychrome sculpture, as it is one of our specialties. In our workshops, irradiation is always the first step before restoration, as this is our preventive policy to avoid cross-contamination by insect of the different artifacts that we have in the workshop. After take place the restoration, you can see in this case of this crease on the cross from the 16th century. It was previously covered with resin thick and heavy paint, and we do what we call the painting removal to go to another layer of painting that was very nice and more interesting. This is typically what we can do in our workshop. Another example is this nice restoration also of a previously badly recovered sculpture with unskillful plaster repair. You can see on the hand of the Marie. And so after a study of polychromies, the exogenous material plaster were they restored, and the recent different painter layers were removed until to reach the original layer. Even if we knew that in this case it was very incomplete, but I hope you can see the difference in before and after, and you can see that the quality of the painting and the quality of the sculpture is very nice after restoration. A more complete example with these crystalline bones, for which I will try to show you all the sequences. So, first operation is to secure the handling for the transfer to our workshop. Firstly, the conservator makes some emergency fixing of polychrome layer that do not hold and that risk falling. This is what we call facing, using some small piece of paper to put on the scale of polychrome layer that were at risk, with some very few glue. Then is the eradication, of course, when it arrives in our workshop. This is just our policy. And then the conservator makes a condition report to assess the conservation issue. For instance, in this case, they do some radiographies to study the point of assembly and the weakness point of the sculpture. They also do a polychromy study, and you can see here all the story of the different painting layer in time. Usually there are a lot. We can also make pigment and biodeterioration by different technique of analysis, infrared, X-ray, etc. In this case, we were also able to date the wood by dendrochronology using the base of the sculpture, using the, you know, this technique is using the gross ring of wood. And finally, the restoration, in this case, just removing of the last polychrome layer, not the whole one. We are not going to the original layer. Then filling gaps when there are some missing parts of polychromy, and color retouch. And here you can see the result. I think you can appreciate. I would like now to introduce the second original technique we use with gamma rays in our workshop. It is the consolidation thanks to radio-curable resins. Indeed, it is historically the first application for cultural heritage we developed in ARC-Nucléart with the consolidation of this nice parquet floor from a famous cabinet maker in our city of Grenoble. This treatment was made in 1970, so just 50 years ago. The idea is to use radio-curable resin, gamma ray being just the tool that makes it harden inside the wood in the bulk after it was impregnated of this, after the artifact was impregnated by this resin. So we have first to impregnate the artifact. We will use vacuum. Firstly, we have to pump the air trapped in the porosity. And then we incorporate the resin with pressure in order to fill the microporosity. The resin will stay in the microporosity thanks to the capillarity force. And the resin is a mix of unsaturated polyester in solution of styrene, so it is liquid. But with irradiation, we will open double carbon-carbon bonds and make a kind of reaction, and the different molecules will combine to give new bonds, and we will obtain a new 3D net between the different molecules, which give a solid. It is, in this case, a thermoset plastic. So this is what we put inside the wood. It is very efficient, very stable, very hard, and but it's a very invasive technique. The artifact becomes more heavy. It can double the weight. The color may darken a bit and enhance the color also. And above all, it is absolutely irreversible. So, taking into account the ethic, we will use only in some very special case. We have to justify the cases when we use these techniques. For instance, we use it as the last chance technique when conventional techniques are not able to meet the conservation issue, or when a powerful mechanical reinforcement is needed to conserve functionality of the artifact. Like in the case of parquet floor, for instance, we want to continue to work on the parquet, so it needs to be very hard. And it can also be justified in the case of treatment of archaeological wood. We will see this after, given the very good chemical stability and of the hardened resin. Here is the case of an extremely damaged polychrome wooden sculpture that was attacked by Xylophagus insect. You can see a lot of powder, and it was really a last chance treatment. Before to do the impregnation, the conservator tried to clean and fix what was possible to do with conventional techniques. It was very difficult because, of course, it was very fragile at that step. Then the different pieces were impregnated with the styrene polyester resin, and after it was irradiated to make harden the resin. And at this stage, it was possible to reassemble and to do again classical restoration with some structural fitting, fine putty, color retouching, support, before it could be exhibited again. I think this is really a good illustration of what is the last chance. And you can see also it does enhance a bit the color, which is not what we were looking for, but in this case, it's okay. I would like now to give another focus on archaeological wood. Abandoned wood can be preserved from mine pests, insects and fungi, for instance, because it is too cold in the permafrost, for instance, or too dry in desert, but mainly it is preserved when there is no oxygen and insects and fungi cannot eat the wood, and it is often when it is immersed in water or buried in sediment saturated with water. In such a case, the wood takes a lot of water. We said it is waterlogged, but the shape is usually well conserved. However, due to biological erosion by some bacteria and because of also of some water hydrolysis, the wood will lose its cellulose. The cell wall of the wood become very fragile, and the capillarity force will cause irreversible collapse if you let the wood dry in air, because when the free water will go away, it will generate this capillarity force that are tremendous. So the conventional method used almost everywhere in the world consists of impregnation of polyethylene glycol, said PEG, to reinforce a bit the cell wall, followed by freeze drying. Freeze drying allows drying without liquid phase. It is sublimation and so on without capillarity forces. That's what is done all around the world, and what we do also in our workshop when there are not other concerns. But in the early 70s, we developed a method with radio-Curable resin for the treatment of a very important collection of medieval wooden artifacts that were found in a lake near Grenoble. We were asked by the archaeologists to find a solution for this collection, and the problem was the impregnation step, as we cannot do like dry artifacts, because the artifact is full of water, and we cannot dry it. It will collapse. So we propose and we do a kind of double exchange, double osmotic exchange, because resin cannot mix with water. So we use several baths to exchange water with intermediate acetone, and then to exchange again acetone to resin. It takes a long time, but it is very efficient. The volume of the artifact is very well conserved, and it improves a lot the mechanical strength, and it ensures a very good stability in humid condition. What's something very important, it avoids the corrosion when metal is associated with wood. That is the main problem of PEG treatment, because PEG treatment, conventional PEG treatment with freeze drying is very hydrophile and will cause corrosion of metal when it is associated with wood. I like this example because maybe you heard about our story in France. We have a long story of fighting with England Navy, and we were asked by our best enemies, Britannic Navy, to treat this gun carriage because they don't know how to do with conventional method because of the presence of a large part of metal, oxidized metal. So this treatment with styrene polyester, we call this treatment the nuclear treatment, was the only solution. So you can see here, on the left the handling in baths of acetone and then of resin, then the iridation. We wrapped the wood with textile in order to absorb the excess of resin in surface. After the resin began to form a gel, we stop the iridation and we control and clean again the surface if necessary before the complete polymerization of the resin. Something important to understand is that we can control of this phase of polymerization of the resin by the iridation. So we can stop, we can complete after, and we can also drive the velocity, the kinetic of the polymerization reaction. So it is very convenient to use this irradiation to control this polymerization. However, this method of impregnation has several flaws. It uses a lot of baths, so a lot of product and then a lot of waste and a lot of time. It can last something like 2 years of impregnation. And also we have a risk of explosion of fire because of acetone and also because of a lot of baths of resin, which is also inflammable. That's why we now use a combined treatment. The idea is to use conventional PEG and freeze drying, but with minimum PEG content to dry the artifact before we can fill the remaining porosity with classical vacuum pressure impregnation of styrene polyester, as we do with dry artifact, and harden it as usual by gamma irradiation. This new combined treatment is very convenient. It is fast. It lasts something like 6 months, no more. Stable, because very few PEG. There are no acetone baths, no waste, because we can reuse both PEG and resin that are not mixed with other products. And the parts that are not impregnated can be reused. So it is really convenient. Here is a very nice example I would like to present you. This is an exceptional Gallo-Roman boat, 31 meters long, almost complete, found in the Rhone River in the south of France, in Arles. So you can see underwater. For this fabulous story, our team was involved from the excavation until the museum. The boat was taken from underwater in 10 sections, as it was not possible to take it in only one piece, nor to treat it in only one piece. Then our team dismantled it before to transport it to our workshop. This is all done in wet condition. This is for instance, the first section, the pro. And as you can see, the pro is very interesting because it was reinforced by iron plates. These iron plates are a problem for conservation, as we know that conventional PEG treatment will lead to corrosion and acidification of the wood in presence of metal due to some salt of metal and sulfur of metal. It will give sulfur acid. That's why it was decided to treat this section by the so-called combined nuclear treatment, while the other part of the whole other section, it was decided to treat them only by conventional PEG treatment. So you can see the PEG impregnation step with our big pool of impregnation. Then the freeze drying. Here you can see also pieces of the mast that was also treated with the same nuclear techniques, because it was well adapted to make it solid enough to be presented in a vertical position. Then the vacuum pressure impregnation of styrene polyester. And finally, the irradiation. You can see here the handling inside the irradiation chamber with cleaning of the excess of resin. After the treatment of all pieces, it was possible to reassemble the whole boat on a special support we made with a company in Grenoble. We do this reassembly of the different pieces directly in the museum. These are the last pieces treated with conventional PEG method before the PRU, and now the PRU, which was treated with the nuclear method. And here is the boat in exhibition. 31 meter long. I think it's the nicest Roman boat in exhibition in the world. So now, instead of a real conclusion, I would like to highlight some collaboration we have with Romania. And I think that collaboration with Romania started almost 30 years ago with Mr. Ponta, then create the IRASM in Magurele. So that IRASM have also a long story in use of gamma rays for cultural heritage irradiation. We had many collaboration about research, for instance, research on behavior of cultural heritage material and irradiation, addressing possible side effects during biocidal treatments. And we also have collaboration in consolidation techniques. And IRASM developed an intermediate scale tanks for impregnation in Magurele. And of course, we continue to have scientific exchange. But something quite interesting is now the collaboration between IFA and CEA, leading to the decision to hold a contest like the one we do in France with the Association of Mayors of France, which offer each year the conservation and restoration of one or more objects from our different municipalities in France. So the idea is to reproduce this kind of contest in Romania. And the first laureate in Romania was this golden doors of iconostasis coming from the Mogoș Palace. It was in very bad state when we first saw it. Insects had damaged the wood so that some parts were completely powdery. After emergency fixing of polychrome layer, then irradiation, the conservator did condition reports study and polychromy study that revealed different layer of painting, of different layer of gold and silver layer. And initially it was thought that the nuclear consolidation with radio-curable resin could be very convenient. But finally, it was not done in order to preserve the possibility to reach the different layer if necessary, because after such treatment, which is completely irreversible, there is no possibility to reach again the different layer. So that's finally a conventional weak consolidation using acrylic resin in solvent was done from the back. It was just enough to allow the cleaning of the last paint layers. Then the reassembly was done at maximum. Of course, the door cannot stand up by themselves because consolidation is too weak. But I think that the result is very interesting. The second laureate was a cathedral, that's a bishop chair, from the monastery of Putna. Here, the polychromy were very thin. After the irradiation, the polychromy were cleaned from dark varnish and fixed as it is possible. And most of the work was done by a Romanian conservator who came to our workshop. I think it is very interesting to have this kind of action and to share experience between our conservators. The missing parts were the foot of the chair were reinstated in a discrete but non-illusory manner, because we don't know exactly how it was before, so we cannot invent. The third laureate were two angels or putti that are also candle holder, also from Mogoș Palace. Here it was necessary to remove a bronzing layer. Bronzing is a metal paint layer that intended to look like bronze or gold. In this case, it was completely oxidized and almost black, as you can see on the candle holder. So it was removed, and you can see after the restoration. So I hope you will agree with me that we have great opportunity to share our knowledge with this collaboration, and that you agree that science and cultural heritage have a lot to do with each other. And thank you for your attention. Mulțumesc.
Thank you very much, Laurent. It was a very nice introduction to this subject of linking nuclear physics with the cultural heritage, and it is a thing that we tried in this school to show that it is really about interdisciplinary field, and you need a lot of perspective to do the things right. So thank you very much for putting that for this presentation.
Thank you.
If there are questions from the audience, they can be written in the question and answer section. And perhaps I should have announced it earlier. Yeah, it seems to be one. So yeah, I also I'm telling you, Laurent, what we try to do at this edition, we try to do a map with the help of the students and a map of Romania, and in each point, because this is an online school and the students are at their homes, and in each location where the students are, we try to find an object of a patrimonium and cultural heritage, to find an object in their place.
Yes.
Perhaps this, and for the first step is to characterize it, to present it, but maybe from these objects that we find in this location, maybe some of them will need restoration. And we are thinking to link this school, our initiative to the contest that you mentioned. And perhaps in the next edition, we will have a collection to propose to you to judge which one.
Great.
Yeah, so this is one of our plans. Let's see if we have some questions. Yeah, it's about SARS-CoV-2. If the gamma rays destroy this virus, coronavirus. Do the gamma rays destroy this coronavirus? It's a question that we have in chat.
If the gamma ray, sorry, I didn't understand. If the gamma ray,
the question is, if the gamma rays that you use,
yes.
You show that you use in these nuclear techniques, if they can destroy this new virus, coronavirus.
Yes, of course. Yes, we have. We also work on this application, this kind of application, and we know that gamma rays is very efficient against coronavirus, which is not one of the most stable virus with gamma rays. There are some viruses are very difficult to kill, but this one is quite easy. Lot of industrial facility use gamma rays for sterilization. And sterilization is mainly against bacteria, not virus. But the doses they use for sterilization is enough to kill any trace of this coronavirus. So we have worked on the to reuse surgical mask. For instance, we know that it is possible to reuse surgical mask after gamma irradiation at doses about 20 kilograms. But it's another topic.
Laurent, you moved a bit, and we hear you lower. I think you are not that close to the microphone. Maybe you did something. We hear you worse than before.
Maybe because I saw I have a problem of battery. Maybe I must.
No. I think when you are looking at the screen, we heard you better. But now, probably you. Yeah. Meanwhile, we have some more questions. So when Laurent is back, we'll pose this question to him. Laurent, do you still hear us? Because I see your camera is still. Vă rog să continuați să scrieți întrebările, chiar dacă nu mai așteptăm un minut, două, până se reconectează Laurent. Chiar dacă nu o să reușească să le răspund acum, dar pot să rămână în chat și să trimite răspunsurile, dar sperăm că se reconectează. Până revine Laurent, să reiau informațiile despre concurs, deci cum v-a prezentat și cum a sugerat și Ioana, și care se ocupă de acest concurs, și Laurent, care este partener. De cel puțin 3 ediții, după cum ați văzut, există un concurs pe care IFIN îl organizează cu ceilalți parteneri, care se adresează tuturor iubitorilor de patrimoniu, și anume, în fiecare an puteți propune o lucrare care are nevoie de restaurare și există o comisie din specialiști care evaluează aceste lucrări și este aleasă una dintre acestea pentru restaurare, și obiectul respectiv ajunge în Franța, în laboratorul despre care ați văzut, și este restaurată. Avem și IFIN, un laborator care folosește tehnici similare de restaurare, și o parte din lucrări se pot trata și în IFIN. Ideea noastră ar fi să promovăm concursul acesta și către voi, și către elevi, și inclusiv pentru ediția de anul viitor a școlii de vară, cine își va dori să mai participe, și să sperăm că ediția următoare va avea loc în laboratoarele noastre și nu sub formatul acesta online, ne propunem, pentru cei dintre voi care participă în acest concurs și trimit astfel de lucrări care au nevoie de restaurare, deci trimit astfel de lucrări în concurs, ne propunem să avem o parte din locuri rezervate pentru aceia dintre voi care ar propune astfel de lucrări. Deci este o oportunitate și să veniți la Măgurele la anul, dar și să salvați cumva ceva care vă este mai apropiat vouă, dintr-un lăcaș de cult, dintr-un muzeu sau din orice alt obiect vechi care ar avea nevoie de restaurare. Puteți să consultați și site-ul IFIN-ului, site-ul concursului de pe pagina concursului de pe site-ul IFIN-ului, unde veți vedea exemple și de alte obiecte care au fost propuse în edițiile anterioare și care obiecte pot să intre în acest concurs. Laurent, observ că nu se mai reconectează. Ioana, mai ești? Ne auzi?
Da, sunt online, da.
Ai putea să dai tu răspunsurile la întrebările care sunt pe chat? Mai avem încă cel puțin 3 întrebări. Dacă nu...
Am încercat. Nu am acces la întrebări, dacă pot să le...
Nu, ar trebui să fie în meniu jos, în bara de meniu, ai question and answers. Dacă nu le ai, ți le citesc eu.
Da.
If you don't know exactly the original paint of an object, what do you do? Do you try to repaint it from your imagination, or you let it blank? Okay, welcome back, Laurent. You are muted. You have to unmute yourself. Your mic, it's not.
Yeah.
Okay.
Can you hear me?
Yeah, we hear you.
I'm sorry. I had a problem with the computer. I was very sorry.
Yeah. No. Meanwhile, I presented them the contest that you organized last year and invited them to participate in the next edition. We have a few more questions if you would like to answer.
Yes,
so
of course.
I don't know if you see them in the bottom menu bar. It should be a question and answer Q&A.
Yeah.
Yeah, you can read them from there. If not, I can read for you.
But here it said that I have no question.
Well, so yeah, you have 5 questions.
I can't see them. Why?
Okay, let me
Question. Sir, you don't have maybe here? No.
Okay, I will read them to you.
Okay.
So it was that first question about coronavirus, and the other one says the presentation was extremely interesting. Thank you so very much. It's not really a question, but more an appreciation post. So this is just an appreciation for your talk.
Okay.
And the next one, if you don't know exactly the original paint of an object, what do you do? Do you try to repaint it from your imagination, or you let it blank?
No, imagination is not is not allowed. In conservation and restoration of cultural heritage is not artist. Is not for artists. It's for restaurant and conservator. So if we don't know, we can clean. We can do our best to conserve what is present, but we cannot do illusion. It is not allowed in the ethic of conservation. So if there are some miss parts, you must leave it like this. Only if you have a very good idea of what was present before, you are allowed to make it not new, but to do some retouch. Painting retouch is allowed, yes, but not invention.
Okay, thank. So another question: what is better to use on leather, polymer or the technique with the acid? So he's speaking about the leather material.
Yeah. So talking about consolidation of leather is a very difficult problem. The resin we used, styrene polyester, is not adapted at all for leather, because when you want to do treatment of leather, you must make possible. You must try to preserve the flexibility of the leather. And with that kind of resin, it's become completely hard, so it is not possible to use this technique. We tried to use other radio-curable resin, elastomer ones, but the result was not so good, because there is also a problem of lubrification in leather. You need to have kind of lubrification of the laser fibers. And so it's very difficult problem. Talking about archaeological waterlogged laser, we use the conventional method with PEG, but not the same PEG, with a lower mass, lower molecular mass, and it stay flexible after this treatment. Yes, you can use.
Okay, thank you. And another question. Do you also deal with the restoration of old paintings?
No, old paintings, we have done some insect eradication of old paintings which were on wood panel, but it was not for the painting in itself, it was for the wood panel. And this is another specialty. This is, well, it is not so different in the technique as, for instance, polychrome sculpture in wood, wooden polychrome sculpture. But the people used to be different. The conservators are not the same. So it's not exactly the same. It's not exactly the same ethic, let's say. So we don't use to do painting.
Okay, thank you. So these are all the questions that we have in from the audience. So
Okay.
Thank you again for your participation, and hope we will meet next time in Bucharest and
I hope so.
or in Grenoble or
Thank you.
laboratory. So thank you very much. Bye.
Bye. Okay. So thank you.